Okay. So once again, you are welcome to today's class. We'll be taking module 6, which is EtherChannel, module 7, which is DHCP version 4, module 8, which is DHCP version 6, all right, or SLAAC. We'll talk about each one of them. We'll understand the concepts that has to do with each of these topics, and then we'll try and see if we can configure one or two things. Now, for EtherChannel, we're going to be looking at the concept of EtherChannel. We're going to look at how to configure it and basically how to troubleshoot it. Now, there are scenarios in which more bandwidth or redundancy between devices is needed than what can be provided by a single link. So multiple links could be connected between devices to increase bandwidth. So, however, spanning tree protocol, which is enabled on layer 2 devices like Cisco devices, is by default. So it will block these redundant links if you have multiple links. So the concept of EtherChannel basically is that you have a particular switch, probably a gigabit switch, and each of those switches are 1 gigabit, for instance, and you intend to increase the capacity of that particular link you are creating from 1 gig maybe to 5 gig. Okay, so EtherChannel is the method to use, and the method is by using physical port links and aggregating them to one logical link, meaning that you have 1 gigabit for each port, and then you put them together. You then increase the number of ports, and there is a chance that you can have loops on those kind of switches. So the spanning tree that we discussed in last class is by default enabled in some of these switches, so it will be able to block some of these loops. But if by any chance the switch is not enabled for spanning tree, you would have to enable it to block it. So this EtherChannel is basically called link aggregation, because you are aggregating these particular links together. So it is link aggregation technology that groups multiple physical Ethernet links together into one logical link. Okay, so EtherChannel technology makes it possible to combine the number of physical links between switches to increase the overall speed of that particular link that you are creating. So this is just an example that we're looking at. I have a particular link here, a switch here. I have another one, and I have another one. And so I am trying to, I now put two physical links here, all right, for each of these switch. All right, I put two cable links for each of this switch. So by putting this, what I'm trying to do is I'm trying to aggregate each of this link. Maybe is a gig. So by putting these two, I'm going to have like 2 gig. Okay, so when EtherChannel is configured, the resulting virtual interface is called a port channel. So the physical interface are bundled together into a port channel interface, as you can see here. So you have physical cables, but logically it is going to see it as one particular cable. So what are some of these advantages? So most configuration tasks can be done on EtherChannel interface instead of each of these interface. So once you have aggregated these physical links into one logical link, all the configurations you're going to be doing is going to be on that one logical link instead of all the physical links. So EtherChannel relies on existing switch ports. So there is no need to upgrade the link to a faster and more expensive connection to have more bandwidth. Okay, for instance, if I am having a switch that is fast Ethernet, and fast Ethernet gives me 100 Mbps, and I want to upgrade it maybe to like 300 or 400 Mbps, instead of changing the entire switch, so it will cost me more money to change the change the switch. What I could just do is enable EtherChannel. Once I enable EtherChannel, I get the required bandwidth that I need. All right. So basically, the concept of EtherChannel explains that load balancing is very, very effective. So if I well, let's put it this way: load balancing takes place between links that are part of the same Ether channel. Load balancing is basically when you want to send traffic from one device to another. You are looking at a scenario where one link will not be overloaded as against the other. So load balancing is when you balance the traffic on each of this. So EtherChannel creates an aggregation that is seen as one logical link, all right, even when you have several physical interfaces. All right, so each channel provides redundancy because of the overall link. So in case one link goes down, you have another one. All right, so when you have when you like to work as an ISP and you are providing bandwidth to companies, this can serve play along very well. You can increase their bandwidth without changing your devices. Now, we have some restrictions you need to bear in mind when you are implementing EtherChannel. All right, interface types cannot be mixed. All right, for instance, you cannot have fast Ethernet port and then you put it together with gigabit Ethernet port. No, it has to be the same port. All right, the same. If it is fast Ethernet, the other one will be fast Ethernet. If not, you're not going to have problem. You are going to have problem. So each Ether channel can consist of 8 compatibility configured Ethernet ports. All right, so Ether channel provides full duplex bandwidth up to 800 Mbps for fast Ethernet switches, or 8 gigabit for gigabit switches. So if you have fast Ethernet, just know you are going to use like 8 ports so to upgrade your bandwidth. If your switches are gigabit, that means it's going to be 8 gig. Now, the Cisco Catalyst 2960 Layer 2 switch currently supports up to 6 Ether channel. All right, the individual Ether channel group member port configuration must be consistent on both devices. Remember, you are trying to put in the physical devices to be one logical trunk. Okay, so if you do whatever configurations you do on one end, you have to do it on the other end so that you will not have configuration issues. All right, so each channel has a logical port channel interface. A configuration applied to the port channel interface affects all physical interfaces that are assigned. And the reason is because in EtherChannel, what you are going to do is you are going to pick the physical interfaces and tie them to a logical interface. So everything you do is applied to it. All right, so Ether channels can be formed through negotiation using one of 2 protocols. All right, one of the protocol is port aggregation protocol. We call it PAGP, port aggregation protocol. The other one is link aggregation control protocol, LACP. So you have port aggregation protocol, you have link aggregation control protocol. So either of this, we are going to look at both of this and then see why we should use any of this and in our configuration. So now let's look at port aggregation protocol. PAGP is pronounced PAGP. All right, it's a Cisco proprietary protocol that aids in the automatic creation of Ether channel links. When an Ether channel link is configured using PAGP, PAGP packets are sent between Ether channel compatible ports to negotiate the forming of the channel. When PAGP identifies match Ethernet links, it groups the links into an Ether channel. So the Ether channel is then added to the spanning tree as a single port. Okay, so when enabled, PAGP also manages the Ether channel. So PAGP packets are sent every 30 seconds, and pack checks for configuration consistency and manages links addition and failures between the two. So this particular protocol basically manages everything about that particular link, especially for the two. So if I configure it on one end of the switch, I must look at the other end of the switch and also do likewise. All right, so that is that. Now, PACP helps create the EtherChannel link by detecting the configuration of each side and ensuring that links are compatible so that the EtherChannel link can be enabled when needed. So the modes of PACP are either on or desirable or auto. Okay, these are the modes. So when you are configuring it, you are going to set it to either on or desirable or auto. When you say on, it means that this mode forces the interface to channel without PACP. Interfaces configured in the on mode do not exchange PACP packets. Okay, but once it's undesirable, the PACP mode places an interface in an active negotiable state in which the interface initiates negotiation with other interfaces by sending the PACP packets. Now, once it is on auto, the PACP mode places an interface in a passive negotiating state in which the interface responds to the PACP packets that is received but not initiate the PACP negotiation. All right, so some of these modes are important, especially when you, the network administrator, is trying to set up the EtherChannel in a particular manner. Okay, so you need to understand the differences between the three. First of all, on the on mode, look at it. It forces the interface to the channel without PACP, and it do not exchange packets. All right, desirable, what do? They exchange packets, but it is set on a negotiating state. All right, place the interface is an active negotiating state in which the interface initiates negotiation with other interfaces by sending packets. So it negotiates the interface with the other one. But once you put it on auto, the interface is in a passive negotiating state in which the interface responds to the PACP packets that it receives, but do not initiate negotiation. All right. Now, look at the summary in the chart. It says that I have switch 1 here, I have switch 2 here. Now, I want to enable EtherChannel using PACP protocol, port aggregation between this link. All right. Now, it says this table shows the various combination of PACP modes on switch 1 and switch 2. So, if on switch 1 I set it to on, I set switch 2 on, I can establish EtherChannel. Okay. If switch 1 is on and switch 2 is either desirable or auto, I will not have EtherChannel configured. If switch 1 is desirable and switch 2 is desirable, they will begin to exchange packets and begin to now form EtherChannel. If switch 1 is desirable, switch 2 is auto. They will exchange packets, and once the desirable one sends packets to the auto, it will now adjust itself. If switch 1 is auto, switch 2 is desirable, EtherChannel will be formed. But if both of them are auto, they will not be formed. So what are we trying to say here? You see, if I have it on, there will be no exchange of packets, but the port will be EtherChannel because I have already set it to on. If I put it to auto, none of them will be able to form EtherChannel because there is no exchange of packets and everybody is waiting for the other. But if I put one of the ports as desirable, all right, and the other as either desirable or auto. There will be exchange of packet, and I will form EtherChannel. So that's the concept of PAC-P. Now, the other one we're looking at is the link aggregation control protocol, which is LACP. All right. It allows several physical ports to be bundled to form a single logical channel. Link aggregation protocol allows a switch to negotiate an automatic bundle by sending the link aggregation control protocol to each of the switches. All right, so it performs a function similar to the PAC-P, all right, with Cisco EtherChannel, because the protocol also sits on the IEEE standard. So LACP provides the same negotiation benefits as PAGP. LACP helps to create the EtherChannel link by detecting the configuration of each side and making sure they are compatible so that the EtherChannel link can be enabled when needed. So the modes of the LACP also include the on mode, the active, and the passive. You see, in the PAC-P, we have the on mode, we have the desirable, we have the what? The auto. All right. But here we have the on, the active, and the passive. The on mode forces the interface to channel without LACP. Interfaces configured on the on mode do not exchange packets, just like the PAC-P that we have looked at. Once it is on the on mode, it does not exchange packet. Once it's on the active mode, the LCP mode places a port in an active negotiating state. In this state, the port initiates negotiation with other ports by sending packets, okay, like we have on the desirable, all right, like we have on the desirable on the active mode. Then now the passive, this LACP port mode places a port in a passive negotiating state. In this state, the port responds to the LACP packet that it receives, but do not initiate, just as like we have in the auto. So in the passive, it can respond to any packet sent to form EtherChannel, but it does not generate. In the active, it generates, okay, and it responds. In the on mode, it does not. All right, so that is for it. So now let's look at the chart for the link aggregation. So you see, if switch 1 is on, switch 2 is on, we have EtherChannel. If switch 1 is on and switch 2 is either active or passive, there is no negotiation. All right. And if switch 1 is active, either switch 1 or 2 is active and the other is passive, we're going to have EtherChannel enabled. All right. But if both are passive, there is no EtherChannel enabled. All right. So you see, the port aggregation and the link aggregation have so much in common. And basically, the concept is to form this particular channel and is dependent on the configuration you make on each of the logical links. All right. So how do you configure EtherChannel? We have some guidelines. The first one is all Ethernet interfaces must support EtherChannel with no requirement that interfaces must be physically contiguous, meaning that the interfaces you're going to use have to be the same at all ports. All right, so you have to verify that. The second thing is that the speed, the duplex speed must be the same. In other words, if I'm having full duplex, I must have both as full duplex. If I am having half duplex, I have both as half duplex. If I'm having fast Ethernet, the other one must be fast Ethernet. If I am having gigabit Ethernet, the other must be gigabit Ethernet as well. Then you also have VLAN match. All interfaces in the EtherChannel bundle must be assigned to the same VLAN. all right, or be configured as trunk, all right. So if I am using port 1 and 2, port 1 and 2 must belong to the same VLAN in switch 1 and in switch 2. Or if I am using trunk, both of them must be as trunk in port 1 and port 2. All right. And then we are going to have the next one says the range of VLAN. So an Ether channel supports the same allowed range of VLANs on all the interfaces in a trunking Ether channel. So if the allowed range of VLANs is not the same, the interfaces do not form Ether channel. All right, even if they are set as auto or desirable. So these are some of the guidelines we need to do. We need to place at the back of our minds before we begin to set up, because if we miss out in any of this, we're going to have a problem. So if you look at this, for instance, we said if these settings must be changed, configure them in a port channel interface configuration mode. All right, any configuration that is applied to the port channel interface also affects the individual ports. So I have this particular switch is 1 gig, is full duplex, and is in VLAN 10. On switch 2, look at it, it has to be also 1 gig, full duplex, VLAN 10. So if any of this is mismatching with this, then we are going to have problem. So step 1, you specify the interface that compose the Ether channel group using the interface range. All right, so you go to the your global interface mode on switch 1. You say interface range fast Ethernet 01 to 2, because you are trying to apply the configurations to the 2 interface. All right, so why are we using range here? We're using range here because we are trying to apply whatever configuration we're doing to both ports, both port 1 and port 2. That's step 1. Step 2 is you create the port channel interface with the channel group, then the identifier, then you put the mode active command. All right, and that is here. So you see, first of all, I go interface range, I pick my range, then channel group, then I give you the group number. All right, so let's say channel group 1, mode what? Active. So the moment I put this mode active, I am trying to create the logical interface, and in the logical interface I am tying both fast Ethernet 1 and fast Ethernet 2. Okay, the identifier specifies the group channel number. The mode active keyword identifies that this is as link LCP channel configuration. That is when we use the mode active command. All right. Step 3 says to change the layer 2 settings on the port channel interface, enter the port channel interface configuration mode using the interface port channel command. All right, so you exit. Once you exit here, then you go to interface port channel 1. This is the channel 1 that you've created. Then switch port mode trunk, then switch port trunk allow VLAN. You allow the VLANs that you want to use. All right, so that is the concept of the Ether channel that you have for these 3 steps. All right, so just before I forget, these are the steps again. Step 1, you enter the interface range to select the ports you want to use. Step 2, you create the channel group. All right, you create the channel group. So channel group, then the group number, then mode active for link for LCP, and then you now go to the interface port channel that you have created, then you convert it to trunk, then you can allow the VLANs. So how do you verify or troubleshoot? All you need to do is show interface port channel, then you give the channel number if you want that particular channel number, or if you just do port channel, it will give you all of it. Or you can say show Ether channel summary, or show EtherChannel port channel, or show interfaces, then EtherChannel. All right. So these commands are what we are going to be using to verify. Okay. How do you troubleshoot? Remember, troubleshooting is when you have problems. And first things first, remember, you need to know the ports that you are using, the speed, the duplex, the mode, and that is in switch 1 has to be the same in switch 2. All right, has to be the same in switch 2. So if I use show EtherChannel summary command, and the output of the show EtherChannel summary command indicates that the EtherChannel is down. How do we know that the EtherChannel is down? From D means it is what? Down. I means it's standalone. P is bundled in port channel. H is hot. So all the information you need is based on this alphabets, these letters that you see here. So you see, how do I know it's down? The D here shows it's down. So I come here, this port, can you see fast Ethernet 0/1, and I have a D here. So this D here shows me that the EtherChannel is down on port 1, and it is also down on port 2. All right. So these are like what I will use to identify, but I come down under the spots and then it gives me the information. All right. So if you view port channel in the configuration, this is what we are going to see. If I say show run and then I say begin interface port channel, it's going to tell me this is channel 1, and I can allow this VLANs and it's strong. This is the fast Ethernet. This is the fast Ethernet that are tied to channel 1. All right. So how you can correct misconfigurations by using the no interface port channel command. So you can use no interface port channel. So it takes away that particular port channel, and then you begin your configurations as you wish. All right. So now look at this. For instance, if I check my summary, EtherChannel summary, you see I have a P here. All I just need to do is come here and look for where do we have a P. Where do we have a P? Can you see? The P here shows that is what? Bundled in what? Port channel. All right. So what you just need to do is you look at the alphabet here, and then it tells you, you look at the table here, and then it tells you what we have. All right. So we have finished chapter 7, past chapter 6, which is EtherChannel. Let's do a particular configuration. Let me come to, where is it? All right. Let me share it with you guys so that we do it together. We'll create or we configure it an EtherChannel. Okay. All right. So this is an activity for EtherChannel. So let's do the activity together, and then and see what we've got. Okay. All right. So we have 4 parts: basic switch settings, then configure EtherChannel with PAGP, then configure an 822.3 AD LCP EtherChannel, then configure the redundant EtherChannel link. All right. So those are the activities we're going to do. Let us start. All right. So start. First of all, part 1, basic switch settings. First of all, assign each switch a host name according to the topology. Okay, this is the topology. So, all right. So I come to switch 1, assign switch name. So I come to enable, configure terminal. Then host name is what? S1. Then I come to switch 2. I do likewise. Enable configure T host name as 2. Then I come to switch 3. Enable configure T host name as what? As 3. All right, so I've configured my host name. Now, it said before beginning your link aggregation between switches, verify the existing configuration on the ports that connect the switches to ensure that the ports will successfully join the Ether channel. All right, commands are provided below. So if I come to switch 1, I'll just check show interfaces, then include Ether channel. So I come to switch 1, this is switch 1. So let me widen this. So interfaces, then I pipe to include Ether channel. Now look at what we have got here. All right, so we have fast Ethernet from 01 to 24, and then the gigabit Ethernet. Now let's see what we have here. It says that these ones, the interfaces are down and line protocol all disabled. Can you see? And then but 21, 22, we have cables that are connected to it, fast Ethernet, then gigabit Ethernet. These ones also, we have cables connected to it. All right, let me see. Okay, we have, do we have any other one that is up? All right, so these are the ones that we have up. So now let's show interface status, and let's see, show interface status. Now let's see what we've got. Okay, based on the interface status, it's showing us that we have, this is fast Ethernet, fast Ethernet, fast Ethernet. And look at it, 100 base TX, 100 base TX. All right, fast Ethernet, and they are all okay. These are the status. Then what else? Show interfaces trunk. Show interfaces trunk. We don't have any trunk interface. All right. So it says configure all ports that are required for Ether channel as static trunks. Static trunks, that means we just configure them as trunk. Okay. And then say if the ports are configured with dynamic trunking protocol or dynamic auto mode, and you do not set the mode of the port to trunk, the link do not form trunk and remain access ports. So the trunk mode for 2960 switch is this. All right, so what we do is we look at the ports. We are on switch 1. So let's look at fast Ethernet 0, 21, and 22. So I'm going to now configure T interface range fast Ethernet 0/21. Let me interface range F0/21 to 22. Okay, switch port mode is what? Trunk. Okay, so that's for this. Then for gigabit 0, 1, and 2. Okay, interface range G0/1 to 2. Switch port mode. You can set it as, how do you set it at trunk static? If I do question mark here, for instance, you see that the mode of this interface can be access. All right, it can be dynamic, that is, the trunking mode is dynamic. All right, but if you set it as trunk, that means you are setting it as static. Is that not so? So switch port mode trunk. All right, so then that is for this switch. Then we come to this switch, fast Ethernet 21, 22, then 23, 24. All right, so interface range fast Ethernet 0/21 to 24, right? Switch port mode is what? Trunk. All right, that's from 21, 22, 23, 24. Good. Then I come here, fast Ethernet 23, 24 is trunk. Interface range F0/23 to 24. Okay, what did I do wrong? Okay, interface range F0/23 to 24. Switch port mode trunk. Okay, then interface range G0/1 to 2. Switch port mode is what? Trunk. All right, sorry, did I do that correctly? G01, G02. All right, so I just hope we did the correct thing. So configure all ports that are required for EtherChannel static trunk. Okay. Then what next? Part 2. It says configure an EtherChannel with Cisco PAGP. All right. So when configuring EtherChannel, it is recommended to shut down the physical ports being grouped on both switches before configuring them into EtherChannel groups. Otherwise, EtherChannel misconfiguration guard may place those ports in error disabled state. So the ports and port channels can be re-enabled after the EtherChannel is configured. All right. So what it means is that we're going to now disable them, then form EtherChannel. So let's do show interface trunk, and then let's see which ones are, because initially we have no trunk interface. So show interface trunk. Good. All right, so what are the trunking interfaces that we have? Look at them here. Okay, on this switch, we have 21, 22, then G01 and 2. All right, that's what we should have here. So we are good here. Port mode encapsulation status native VLAN. Okay. Okay, so let's see. On switch 1 and switch 3, add ports 21. That's on switch 1. Where is switch 1? Let's see. Switch 1 and switch 3. All right. Add FA21 and 22 to EtherChannel group 1. All right. And then the mode is what? Desirable. All right. The mode desirable option enables the switch to actively negotiate to form a PAGP link. All right. So we have to shut down the interfaces first. So let's come this way. Configure T interface range F0/21 to 22. Then we say what? Shut down. Then we come down to this port 21 and 22 as well. Alright, the interface range F0/21 to 22. Shut down. Okay, so once we shut down, then the next thing to do is to do what? We now create the EtherChannel group 1 mode desirable. All right, so we come in here where, remember, we're still in that particular interface mode. All right, in that particular interface mode. So we'll say channel channel group 1 mode is desirable, right? Shut down. Then I come to this switch, same thing, channel group 1 mode is desirable, then no shut down. Oh, sorry, what did I miss? Channel group 1 mode is desirable. Okay, then I do no shutdown. All right, so the interface is active. All right, so what's the next thing now to do? We configure the logical interface to become a trunk by entering the interface port channel number. Remember, we created it as the channel group as 1. So this becomes an interface. All right, so now we come to switch 1. Now, this time around, we are going to exit these physical interfaces because we have merged the physical interfaces into one logical interface. So the next thing now, I can exit. Then I will enter into this channel 1 interface. All right. So interface port channel 1. All right. Then switch port mode is what? Is trunk. All right, that's what I do for this. That is, now we're dealing any points we do with this channel, any configuration we do with channel 1, it applies to those other interfaces. Then I come here, same thing. I exit, I say interface port channel 1. Switch port mode is what? Trunk. All right, so having done that, then we verify our port channel status. So let's do show EtherChannel summary, and then let's check. So let me come to switch 1. All right. So show EtherChannel summary. Good. So you see the P is telling me I am doing what? PAGP, pack P, which is I am up here, and that's what we are supposed to see in the P here for both port numbers, for both here and here. All right, so we are good with that. All right, so if the channel does not come up, then you would have, so let's check the other switch, this switch here, and so show EtherChannel summary. Okay, so you see we are good, we're good. All right, so we'll configure LACP on it. So we configure port channel 2. All right, so this time around we are going to now do, maybe since we have done PAGP here, we are going to do LACP active here, then we'll just do port channel 2 for LACP here. Okay, so we enter switch 1 and go to the gigabit interface. Config T, then interface range is going to be G0/1 to 2. All right, so then remember we have to shut down the interface before configuring EtherChannel. All right, so G0/1 to 2. So I'm going to come here also, G0/1 to 2, switch to interface range G0/1 to 2, shut down. Good. So come in here and switch 1. So I now say channel group 2. We used 1 in the other one, so group 2. Mode is what? Active. Now you see in the PAGP I use desirable, that is to set pack P, but for the LCP I'll use what? Active. All right, then no shutdown. Then I come to this switch, the same thing I did. So I will say channel group 2 mode. Mode is what? Active. Then no shutdown. All right, so you see I have done for this and this. So now I'm going to now enter the interface mode of the channel and make it strong. All right, so say interface port channel 2, then switch port mode is what? Trunk. Then I come down here, interface port channel 2, switch port mode is trunk. Good. So having done that, we can verify our status. For instance, we come to switch 1 here, and then we say show EtherChannel summary. So you see, this is the first one that we did, PAGP, and then this is the second one that we did. All right, so our EtherChannel is done for this switch. But if we come to this switch, we should also see it, but in just one. So show EtherChannel summary. So you see, LCP is done for this. Okay, then configure the redundant EtherChannel link so that spanning tree can work. So we will come to switch. So we'll use EtherChannel 3. We use 1 here, we use 2 here. So let's come here. There are various options for channel group. So we'll come to switch 2, which is this guy here, and configure terminal. Then we'll use this interface. Look at it, 23 and 24. All right, so interface range range F0/23 to 24. Now channel group 3 mode. All right, so look at it. We have done mode as desirable for PAGP. Is that not so? We have done mode as desirable for PAGP, and then well, if we put it on, that is unconditional. If we put it passive, that is LACP only if a LACP device is detected. Okay, and that is what we're supposed to do here. Look at it, either active or passive. Can you see? All right. So you see the example we're saying that you will have this. You see, these are the explanation. So passive is detected in this guy here. All right. So what we're supposed to use is what? Passive. All right. Mode passive. All right. Good. So if we do passive for the particular link, then we'll enter the interface. Exit, then interface port channel 3, switch port mode is trunk. All right, so then we come to switch 3, which is switch 3 here. And switch 3, we're going to put it as active, right? Let's see what's the instruction. The instruction says add ports 23 and 24, which is 23 and 24 on switch 3, to channel 3 with the channel mode as what? Active, which is true. The active command indicates that you want the switch to use the unconditional. All right, so let's set it to active. Okay. So config T interface range F, is it FA? Think so. It's FA, fast Ethernet. Yeah. 0/23 0/23 24. Okay. Right. Now, having done that, then we now come to channel channel group. What group number are we using? We're using 3. That's the one we use in the other one. Channel group 3 mode is what? Active. Okay, mode is active, no shutdown. All right, so we have done mode is active for that, and so we go to the interface channel, exit, then interface channel, interface port channel 3, switch port mode is strong. Good, so we are there. So let's verify and see whether our spanning tree is active. Okay, so we go to switch 1. All right, see here, here. So switch 1 says show spanning tree active, and what do we have? We have a blocking state here as an alternative, and we have a forwarding here, right? And which is okay. Look at it. This is what we're supposed to have: forwarding and a blocking, right? So I think we are good. So then in that case, configure terminal. So you see port channel 2 is not operative because spanning tree protocol placed some ports in blocking states, which is this particular port here. Then unfortunately those ports are gigabit ports in the topology. So we are to restore these ports by configuring switch 1 to be primary route for VLAN 1. All right, so we could set the priority to 24576 to set it lower than the other this thing. So to do that, we just go to spanning tree VLAN 1 root primary, right? Or we can now give it the priority that we want. Either you say primary or you give it a priority of this. Okay, so basically that is our configuration. So let's check our results, see where we are. Assessments, oh, 100%, 100 over 100, 40, 40. All right. So I think we are good on this one. So we're going to take a 5 minutes break. Then we come back and then take IP version 4 and then IP version 6. All right. That's DHCP, sorry. DHCP IP version 4 and then version 6. So I'll be back in the DHCP version 4. Now, what is the concept of DHCP? All right, what is the concept of DHCP? DHCP is simply Dynamic Host Control Protocol. And the idea of DHCP is that you have your clients, you have your computers within your network that needs to get connected. They need to gain IP addresses. They need to get DNS servers. They need to get lease time. They need to get some information for them to properly connect to the network. Now, you can give this information statically, or you can give this information dynamically. Now, DHCP is just Dynamic Host Control Protocol, and version 4 means that it's giving IP version 4 addresses, giving IP version 4 addresses to clients. So a dedicated server or a dedicated machine can be enabled to be able to be giving out these particular IP addresses. So however, in a small network or a small setup, you can use a Cisco router to configure DHCP to be giving out IP addresses. But in a very big enterprise network or campus network, it's always recommended to have a separate machine to be able to do that. So the DHCP concept actually gives out these particular IP addresses automatically. But how does it do that? The clients actually connect to the network with a list of IP version 4 IP addresses until that list is expired. If it expires, then the client must then contact the DHCP server to request for another IP version 4 address. So this list mechanisms ensures that clients that move or power off do not get address that they do no longer need. What are we saying? If my system gets an IP address and this IP address it gets is leased for, let's say, 24 hours, what it simply means is that even if my system goes off and comes back again, that particular IP address is reserved for that particular system within these 24 hours. So within these 24 hours, the IP address leased to a particular machine does not change unless you flush out the DHCP pool. So when the lease expires, the DHCP server returns the address to the pool where it can be reallocated to any other person. But if that particular machine needs it, it will request for it. So how does the DHCP operations takes place? All right, there are like 4 stages that you can see here. The first stage that actually happens is what we call the DHCP discover. All right, the DHCP discover, where the client is going to now send a broadcast, will connect the network and send a broadcast because it is required. It says, I would like to request for an address. Okay, then this message is a broadcast because this client do not know how many DHCP servers are there on the network, where they are located, and things like that. It doesn't have an idea. So the idea, that's why it sends a broadcast. So once it sends a broadcast, the DHCP server then receives this broadcast and sends a unicast as an offer. You say, oh, hey, I am DHCP, I exist on this network. Can I offer you this particular, this my service? All right. So once it sends that, then the client now accepts the offer. All right, accepts the offer and sends a request. It says accepts the offer and then sends a request, and then finally the DHCP server will now acknowledge it. So there are basically 4 things. First is the discover, the second is the offer, the third is the request, and then the fourth is the acknowledgement. So that's like the correspondence that goes on between the DHCP server and the client. Now, prior to the expiration of the client, the client begins a 2-step process to renew the lease with the DHCP server. All right, and to renew it, it sends a request. All right, and then the server sends an acknowledgement, and the request is sent by the client, then the server now sends the acknowledgement. So how do you configure DHCP on a Cisco router? For instance, you have a network here, you have a DNS server located here, then you have this router. So you have a small network, you can configure DHCP to serve on this particular network. So the first step is you have to exclude a range of IP addresses. So if I have an IP address, a block of IP, let's say 192.168.10.1/24, for instance, and I want to exclude, then I'm saying, okay, I am excluding from 1 to 20 or 1 to 10. I am excluding the first 10. What exclude simply means is that out of the pool of addresses to be given out, you are trying to tell the router, please do not give out IP addresses that range from 1 to 10. Okay, and usually these IP addresses that you are excluding, sometimes you assign them statically to your DMZ, to your servers, and things like that. So a single address or a range of addresses can be excluded by specifying the low address and the high address of that range. So excluded addresses should be those addresses that are assigned to your routers, to your servers, to your printers, and other devices that you have assigned manually. So we use that by using the command IPDHCP excluded address. Then you give from the lower, that maybe from 1 then to the higher, 1 to maybe 10 or 1 to 5 or stuff like that. So that is to start. So you first of all, by excluding a particular range of IP addresses. Step 2 is to define the pool name, DHCP version 4 pool name. So you do that by saying IP DHCP pool, then you give the pool name. You now say IP DHCP pool, maybe you say management pool, or maybe arts pool, or whatever pool that you want to create. All right, so you create the pool name, and then you give a pool with a specific name and inputs the router configuration mode, which identify this particular prompt. So after that, look at what we're talking about: the network, then the network address, default router, then that is the IP address of the router that every client is going to get. That's the default gateway rather. Then DNS, you give the DNS that you want the users to get. Then domain name, the domain name you want to get. Then the lease time you want to get. I mean, these are some of the information that the DHCP server will give out to the client. So configure the DHCP version 4 pool. The address pool and default gateway routers must be configured. Use the network statements to define the range of the available addresses. So the default router command defines the default gateway. All right, so this is it like we said. So network, then you give the network number and then the mask, or you put the slash notation. We're going to see examples. All right, so for instance, now I say IP DHCP excluded address 192.168.10.1 to 10.9. So what it means is that the router is not going to give out any IP address between 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, it's not going to give out that. IP DHCP excluded address 10.254. All right, this address is also not going to be given. Now, the question is, why is this command separate from this? Why aren't they on the same line? It's because you see here is a range from 1 to 9 is a range, but 254 is not a range. So it is another IP address with that is not within that range, but probably is the last. Then after I've excluded, which is step 1, step 2 is define my pool. So IP DHCP pool, then my pool name. You can say LAN pool 1, LAN pool 2, or Faculty of Arts, Faculty of Social Sciences, whatever. You give your pool name, then the network address and the subnet mask as the block you have. Then the default router, then that's the IP address that you assign to if it is this network here, that's the IP address on this interface here. All right, then DNS server, the IP address of the DNS server. All right, then the domain name, you give the domain name. So you see, it's very simple. So we're going to do a packet tracer to configure DHCP. All right, we can also verify whether our DHCP is running by either using show DHCP IP DHCP binding, or our show running config. All right, or show DHCP server statistics. We're going to see that. So if I do show running config section DHCP, is going to now bring out the configuration that we have done on our DHCP. All right, but if I do binding is going to tell me the end devices that have been automatically connected, have been giving out IP addresses. All right, so I have like this IP address. So all right, that's binding. And then statistics is going to now show me the detailed statistics that we have, how many requests, how many discover, how many decline leases, and stuff like that. All right, so this is my system. You can go on your system and assign the IP address. So now if you want to disable the DHCP service, you just say no service DHCP. Simple. If you want to enable it, service DHCP. All right, now what is DHCP relay? Now, relay simply means that you are setting up a DHCP somewhere else, and you want a particular router to forward the request of the DHCP to another device. In this scenario, in this topology, you see here that we have a DHCP server here. We have a DNS server. So what I could do is I can configure on this router a DHCP relay to tell everybody on this LAN that if you are looking for your IP address, this man will relay your request to this particular server here. Okay, so in a complex hierarchical network, enterprise servers are usually located centrally. So these servers may provide DHCP or DNS or TFTP and FTP services. All right, so maybe like your we call it DMZ. All right, so in that case, you set up everything under DMZ, so the request is always going to be forwarded to this particular point. So how do you configure it? I go to my router. So I'm going to be on this router now, and so that I can relay the DHCP request here. All right, so you enter G0/0, then IP helper, then the address. All right, look at it, 11.6. Now, what are we looking at? See, look at it, IP 11.6. So, and I'm configuring the IP helper on this interface, on this particular interface. That's where this IP helper is being configured. All right, so IP helper, then I point it to this. That's all. So if I come to show IP interface G000, look at it, it will tell me internet address is 10.1, this is this, but it will tell me helper address is what? 11.6. All right, so these are other services that can be. So IP version 4 is not only the service that that the router can be configured to relay. So by default, the IP helper address command forwards the following 8 UDP service. The time, the TACAS, this one is for authentication, DNS, DHCP, FTP, NetBIOS, and things like that. So let's do a packet tracer activity to configure a DHCP. Let me see. Okay. Let's configure. Let me share it with you guys. Okay. So I have this here. I have this here. So this is the activity we're going to do. You see this is a DNS server here. This is a Cisco server. This is a public site server. And then let's see the activity. We're going to configure DHCP version 4. And so these are the details. So let's start. There are 4 active parts for us. We configure a router as a DHCP server, then configure DHCP relay, then configure a router as a DHCP client, and then we'll verify connectivity. Okay, so let's go ahead. It says addresses that have been statically assigned to devices in the network that will use DHCP must be excluded from the pools. This avoids errors associated in leasing out the DHCP. All right. So in this case, the IP addresses to router 1 and router 3 LAN. Where is router 1 LAN? This router 1 LAN. This router 3 LAN. Okay, the IP address must be excluded from the DHCP. In addition, 9 other addresses are excluded for static assignment and stuff like that. So we will enter router 2, configure router 2 to exclude 10 addresses from LAN, router 1 LAN. All right, so let's enter router 2. Let's enter router 2. This is router 2. Enable, configure terminal. So what do we do? Exclude our IP addresses. IP DHCP excluded. Then 192.168.10.1 to what? To 10. All right. 192.168.10.10. Okay. So we have excluded these IP addresses, this range from 1 to 10. All right. So configure router 2 to exclude the first 10 addresses from router 3. From router 3 LAN. So where's router 3 LAN? Router 3 LAN is 30.0. So what we are going to do, we're repeating the command, but 30 network. This is 30 here to 30 here, right? Okay, so we have excluded the first 10 IP addresses here. We have excluded the first 10 IP addresses here. Now, create a DHCP pool on router 2 for the router 1 LAN. So we're creating a pool for this, and they say we should call it R LAN like this, and it's case sensitive. Okay, so I come back here. So then we say IP DHCP pool. Let me just paste it as we copy it. All right. Then what is the pool now? The network. The network. Remember, LAN 1 is 10.192.16.10. 192.168.10.0 network with the subnet mask as 255.255.255.0. Okay. Then our default server is default router as 192.168.10.1. 10.1 is the IP address of that interface. Then our DNS server is the IP address given as 254 that we excluded. Where is it? Okay, look at DNS here. So DNS server would be 192.168.20.254. All right. So we have done for this LAN here. All right, we have done for this LAN. So they say we should create a DHCP pool on router 2 for router 3 LAN. Okay. So, and then configure the DHCP pool to include network address, default gateway, IP address of DNS. All right. So, and we should refer to the table. Where's the table? Router 3 LAN. The DNS is 254. Right. So we're good. So we now. Okay. So IP DHCP pool is router 3 LAN. Okay. Network is, where's the router 3 network? Look at it. 192.168.30.0 network. 192.168.30.0. 255.255. Sorry. 255.255.255.0. Right. All right. So then default router would be 192. Look at the default router here. See it here. So 192.168.30.1. Then DNS server. Look at the IP here. 20.254. 192.168.20.254. Okay. All right. So let's see. All right. So we have done that. Now, part 2. Configure DHCP relay. Configure router 1 and router 3 as a relay agent. Where's router 1? This is router 1 and router 3 to relay to this man here, so that these systems here in this LAN will come and get their IP addresses here. All right, because this is where we configured it. We didn't configure the DHCP here or here. We configured it here, so we are relaying it here. All right, so and the relay is going to be on this particular interface and this particular interface. Okay, so I will enter router 1. Router 1, enable configure terminal. Excuse me. interface G0/0, then IP helper address. Now remember, this is where our helper address is. This is the IP address of this router. So we come here, look at it. Where is router 2? See router 2 here. So this interface, this serial interface 10.1.1.2, and then this one here is 10.2.2.2. So our helper address, IP helper, come, where are we? We're supposed to do it. Okay, sorry. We're supposed to do it on this address. IP helper address is 10.1.1. Let's be sure. .2. That's .2. Okay. That's the helper address for this. Then we come to this router. Okay. This interface. I think it's also G0/0, if I'm not mistaken. So enable interface G0/0, then IP helper address is what did we get here? 10.2.2.2. 10.2.2.2. right? Good. So that's the helper address. So configure host to receive IP address information from DHCP. So configure host PC1, PC2 to receive IP addresses. So I come to PC1 here, IP configuration, and it's this. So you see it automatically got the IP address automatically. We got this 10.11. See this subnet, this is the default gateway, this is the DNS. Okay, then we come for this PC here. You see the DHCP, you should be able to get, wow, so you see it has just gotten immediately. So we got the IP addresses here. Okay, so we have configured that and verify. So we should verify that hosts have received their addresses. So we have checked hosts have received. So we can even come to here and check say show IP DHCP binding. Can you see? If you do IP DHCP binding, you see this person have gotten an IP address, and then the other PC, this is for LAN 1, this is for LAN 2. These are the IP addresses that we got automatically. So configure a router as a DHCP client. So just as PC is able to receive IP version 4 addresses from a server, router interface has the ability to do the same. So router 2 needs to be configured to receive addresses from the ISP. This is the internet. So we need to configure this interface so that this router will receive automatic IP from this automatically. Okay, so let's enter router 2. And we go to the interface. That's G0 interface G0/1. Then IP address, we configure it as what? DHCP. All right, if we want to give you the IP address statically, we just say IP address, then we give the IP address and its subnet mask. But since we wanted to get IP address DHCP. Okay. All right. Then no shutdown. Right. So once we have done that, we can verify that our interface G01 has an IP address. We show IP interface brief. Okay, so can you see? Let's see where we look at it. It's configured as what? DHCP. All right, so it's going to get the IP address automatically. All right, this is it. All others are manual, which is static. Okay, so let's check our result and see what we have done. Let's see, assessments. Okay, 100, 102, 103. So we are correct. All right, so this is great for DHCP. This DHCP, we are done for DHCP. So version 4. Okay. We have done the DHCP clients. We have done it. So now home routers are typically already set to receive IP version 4 addresses. So we'll come to do wireless. This is wireless. So when we come to do wireless, I'm going to skip this slide. And when we come to do wireless, we'll just do it all together. All right. Now, module 8 is talking about DHCP version 6 or SLAAC. Now, I don't know whether you guys are tired or we should continue. Well, let me take questions. Let me take some questions here briefly. Okay, SLAAC or DHCP version 6. Now, you see, we did DHCP version 4 and DHCP is DHCP and it's just a system to give out IP addresses. Now, the version 4 that we looked at is just to give out IP version 4 addresses. Now, in this case, we're looking at how to give out IP version 6 addresses automatically. All right, so that's what chapter 8 is talking about. And first of all, you can assign your system to be able to give out IP version 6 addresses automatically. And the best way to do that, let me share my screen, my system. Come in just a minute. So that I will show you how to do that. Just a second. Okay. So share. Okay. Now this is my network and sharing. It's still not shared. All right. I'm sure you can see it now. This is assuming my network. So I want to give out. I want to let's say assign IP addresses, IP version 6 automatically. I come, for instance, I just right click properties. Okay, you go to properties. Now in your properties, you can come here, either IP version 4. This way you can assign IP version 4, but we are talking about IP version 6. So if I click here, can you see IP version 6? So if I want to assign it manually, I just click here and then I put in the IP version 6, then the subnet, the gateway. All right, but if you leave it automatically, it picks it directly from the DHCP server. Okay, so let me.
I've not seen that, sir.
Okay, so now this is just what I just showed you. So Windows has a way you can assign automatically if you click these buttons automatically, or you now click it to assign it manually. All right. Now, every system has what they call the linked local address. All right. So if you do IP config, so let me go to my command prompt, and then I show you guys what this means. Let me share it. Share my command prompt. Okay. Okay, just a minute. My generator is going down. Let me just refuel it just a second, please. Okay. So I'm trying to show you on my system. Let me share my. Okay, I've shared it. All right. So if I do IP config, IP config. All right. It will give me, look at it, it will give me a set of linked local IP version 6 address. Okay, can you see for each of the interfaces? You see, this is for my virtual machines, this is for my loopback, this is for my VMware, and then this for my wireless. Can you see linked local address? And then you give me a particular address, and that's the point I want to show you here. So once you do IP version 6 by default, you get a particular IP link local. So the IP version 6 link local address is automatically created by the host when it boots and Ethernet interface is active. The interface did not create the IP version 6 GUA in the output as you have seen, because the network segment did not have a router to provide the network. All right. So note the percentage that you see, this percentage here, like you see here, percentage then 21. And then the number at the end of the linked local is known as the zone ID. Yeah, zone ID or the scope ID, and is used by the operating system to associate the LLA with the specific interface. All right. So how do you assign it? You can assign it dynamically or statically. Dynamically, you have what we call the stateful, and then you have stateless, and you have what they call the stateful. What is the difference? The stateless, you say no device is tracking the assignment of the IP version 6 address. The stateful says a DHCP server is managing the assignment of the IP version 6 addresses. That's the stateful. All right. And in the DHCP server, you have like the router advertisements, you have the host that will contact the server, and then you have the host that obtains the default gateway. So the stateful tells you that, like how we have configured the IP version 4, it also can configure, you can configure the stateful for IP version 6. The stateless is saying that you don't need that DHCP server to set it up. It has what we call a SLAAC, stateless, and we'll get about it. It says the router sends a router advertisement, which is the messages, and then the host will actually receive it. Then you also have the SLAAC with the DHCP server, and we're going to look at both of them. So we said that all stateless and stateful method in this module use ICMP version 6 router advertisement messages. All right. And although host operating systems follow the suggestions of the router advertisement, the actual decision is ultimately up to the host. So there are 3 messages that we need to know when the system is trying to get the information, like we did for the IP version 4, where you're going to have the discover, the offer, the advertisement, the acknowledgement, and stuff like that. So here we have the A flag, we have the O flag, we have the M flag. The A flag starts for the address auto configuration flag, and it signifies to use the stateless address auto configuration. All right, so to create the IP version 6. So you might ask this question: what is this SLAAC? SLAAC is just stateless address auto configuration. All right, and then the O flag is the other configuration flag that signifies that additional information is available from a stateless DHCP server. So the A flag tells us that the address auto configuration flag implies stateless address auto configuration. All right. The O flag says that there are additional information that needs to be gotten. The M flag, managed address configuration flag, signifies to use a stateful DHCP server. All right. So most of the stateful setup use the M flag. All right. So look at this, for instance. You have a router here, you have a switch, you have a client. So this particular client is trying to get a message, an IP address, an IP version 6. All right. So what has it done? The RA, remember we talk about, is what? The router advertisement. So it sends the this guy sends the request, this guy sends the advertisement, and then we said SLAAC is by default. All right. So if SLAAC is by default, that means it's going to be using the A flag, and you see this A flag is going to be 1. Then O and M will be what? 0. Okay. But if you are using the DHCP server, you will see that the A flag is 0, and then the M flag is what? 1. All right. And so that is how it actually works. So if it's sending the message to the client, and the flag here is 1, it means that it's using stateless, and that is usually by default. All right. But if it's if the flag is 1 and O flag is 1, it means that it's using stateless, but it's also getting additional information like the DNS, like the other information that it will require. All right. So that is what this guy is saying. All right. So, but if it's using M flag as 1, that is the DHCP server is the one that is giving it every other information that it needs. Now, SLAAC is a stateless service, which means there is no server that maintains the network address information to know which IP version 6 are being used and which ones are available. SLAAC sends periodic ICMP router messages, all right, every 200 seconds, providing addressing and other information for the host to auto-configure their IP version 6 address based on the information in the router advertisement. So a host can also send router solicitation messages requesting for an RA, which is router advertisement. So SLAAC can be deployed as SLAAC only or SLAAC with DHCP version 6. That's where the flag comes into play. Okay. All right. So how do we enable it? Very, very simple. First of all, you look at the router that you want to enable, the interface you want to enable. For instance, I go to interface show IP version 6, this, and it gives me this. So I enter the interface, and then I enable it. So we have the link local address, usually starts with FE80. All right. Okay, and then you have this, the global unicast address. Then you have the IP version 6 all nodes, this. So here you log into this interface, global mode, interface G001, and then you now assign the IP address. Okay. And how about SLAAC? How do you enable SLAAC? What is the difference? Because you see in in this one, we're looking at SLAAC, how we enable it. You enter the interface and you see what? IP version 6 unicast routing. And that is all. So here you see show IP version 6 interface G0/1 tells us the IP addresses that are there. Now, here, if I come to my router, my system, sorry, and I do the IP version 6 and IP config, look at it, I get the IP address, I get the linked local address, but the ones that I'm interested in is, you see it in yellow, IP address, and then the default gateway. All right, all these ones are issued automatically by default, but these are the IP addresses that the router has given me, this and this. Now, the reason is because my A is flagged, so I am using stateless. My flag is A, the value is 1, so I am using stateless on this particular interface. Okay, so a router sends router advertisement message every 200 seconds or when it receives a router solicitation message from a host. IP version 6 enables hosts wishing to obtain IP version 6 addressing information and sends an RS, which is router solicitation or rather router request message to IP version 6 router multicast address of this. So this figure shows how a host initiates a SLAAC. This host, how does this initiate a SLAAC? All right, after booting, it sends a request. The request is called the router solicitation. That's this guy here. It sends a request message to all the routers. All right, then you know IP version 6 do not do broadcast. So what they do is multicast. So it sends it as a multicast. All right, that is why it uses this address. So then once the router 1 receives it, it generates a router advertisement and send the message to as a unicast to this particular node. All right, using the information that it's given. Okay, how do you detect duplicate address? So a SLAAC host may use the following duplicate address detection or DAD. All right, to ensure that the IP version 6 GUA is unique. Okay, so duplicate address is when two devices are given the same IP address. So you can only have one device having the same IP address on the network, but not two devices having the same IP address. So that could cause a problem. So if no other device responds to the neighbor advertisement message, then the address is virtually guaranteed. So the host sends an ICMP neighbor solicitation message with specially constructed solicited node multicast address containing the last 24 bit of the IP version 6 host. All right, trying to find out if there is any other device that has that particular address. But if there is no response, then it assigns it to the host. All right, there's no response, it assigns it to the host. That is SLAAC that we looked at. Now on the other side, this is for the DHCP server. How does it do? The host sends a router solicitation message. The router responds with the advertisement. The host sends the DHCP version 6 solicit message. The server responds with the advertise. The host responds with the server, and then the server now sends a reply. Now, what is the difference between this and the SLAAC? The SLAAC is automatically done. Once you enable it, you just give the block and then it automatically does. But the server, you have to configure it to be able to get this particular information and give it to the particular client that is requesting for it. So the process is a little bit different, especially when the flag you are dealing with is the M flag. All right, so here if you have an interface that you want to configure that, all you just need to do is log into the particular interface. You see the other one, you just log into the global mode and IP version 6 unicast routing. Here you see IP version 6 ND, that's other config flag. All right, and then you end. So if I now come and the ND stands for what? Neighbor discovery that we have here. Let me show you. All right, where is it? Where is it? Where is it? I think we have it somewhere here. All right. Okay. Okay, I think I missed where I saw it. All right, I missed where I saw it. Right. So the whole idea is you want to, where are we? Okay, right hand, this is where we are. So the stateful IP version 6 is enabled using the IP version 6 ND managed config flag interface command. All right, setting the M flag to be 1. Remember that if you want to set M flag to be 1, it's because you have a DHCP server and you want DHCP server, or you want to configure a DHCP server and you want it to be the one to be giving out these particular addresses. So the highlighted output in the example confirms that the router advertisement will tell the host to obtain all IP configurations from a DHCP server when the M flag is 1. So how do you configure it? It's also very, very simple. All right, the router provides, Cisco routers are powerful devices. Similar networks, you do not have to separate devices to have DHCP version 6 server or client or relay agent. The Cisco IOS can then be configured to provide these particular services. So you don't need to have separate. So specifically, it can be configured to be one of the following. One is DHCP version 6 server, where the router provides the stateless or stateful DHCP services, or DHCP client, where the router acquires the IP configuration from a DHCP server, or DHCP relay agent. All right, so the router can perform any of these roles that we have done. All right, it can have done. So the 5 steps to configure and verify a router as a stateless server. First of all, enable the IP version 6 unicast routing command. You do that in the global mode, as we have seen earlier on. You enable that. Then you define the pool name. So IP version 6 DHCP pool, you give it a pool name, and then and you do that in the global configuration mode. Then you now configure the DHCP pool with options. Common options like DNS server, domain name, and things like that. All right. So how about the stateless? Okay, this one is still stateless. We're looking at it. Okay, let me go. I want to go to stateful. Aha, this is stateful. For stateful, you enable the IP version 6 unicast writing command, then DHCP version 6, IP version 6 DHCP pool name, you give it. Then you configure the DHCP pool with options command to include the address prefix command. Then bind the interface to the pool using the IP DHCP pool name and then the interface command. All right, that is for the DHCP. All right, so I think basically that is it. So if you do show IP DHCP pool, it will tell you whether it is stateful or it is stateless. All right, once it is stateful, you will see the information that it gives you. If it is stateless, it will also give you. All right, so if you do the binding, it's also going to show you the devices that have received IP addresses, the clients that have received IP addresses from the server. For instance, you see this IP address was given to a particular machine. This is the lease time or the lifeline that it has. So it's going to expire by these details, things like that. Okay. So how do you configure it as a relay? As a relay, for instance, this is the stateful server, all right, and you want to use this as an agent. So for all you need to do is you enter the interface, this interface that you have, then you say IP version 6 DHCP relay destination. Destination is now going to be the IP address of this router here. And you look at it here, and then the interface that it will go out. This is the interface it will go out. All right, so that's all. as the relay. Okay, so I think that will be all for this particular class. So we have done chapter 6, chapter 7, chapter 8 today to cover these particular topics that we have